Coming to the stage is one of our favorite people, Mr. Aaron Sullivan from Rackspace. Please welcome Aaron.
Good morning. I look at the progress we've made over the last few years, and I look at you in the audience, and I think there's one thing that we all have in common. We enjoy watching what happens when a small group of dweebs and visionaries gets together with a really interesting idea, and we like watching it grow into reality. And I think we've been watching that happen over the last few years here with Open Compute, and more so every year. If you think about the number of designs we have today and the amount of adoption we have today, just think about what that's going to look like next year. I want to talk about another aspect of the future for Open Compute, present you with a vision of that. And when we talk about the future, our experience is often pivotal to how we see it. And sometimes our experience helps us see what we think is a future very clearly. And when we talk to each other, maybe it seems a little blurry. And some people for a little while don't see it at all. So my goal here over the course of the next 20 minutes or so is to help you see the future as we see it for open hardware development. Because we've come this far, but we have a lot further we can go. I want to talk just a little bit about our progress and how we got here. And this is Rackspace's story with Open Compute. And then we'll move from there to talking about that future vision. So today we ship many applications at Rackspace on Open Compute equipment. We do it in our back office, and we do it with a number of our front office applications, and we plan to continue increasing the footprint of OCP within our install base, our existing and new applications. And one of the ones that we're most excited about is one that we built and launched last year. We call it OnMetal. And I don't think we could have done OnMetal without having Open Compute and OpenStack where they were. People wanted a special service that we could vertically integrate using both of those components and do something that offered a really distinctive value that couldn't be done anywhere else. So a new model enabled by these types of movements that creates new market value for us and our end users. And I think that for us, we had our own little indicator about how adoption of this technology is accelerating when last year in September, VMware announced that they were putting out their Evo rack reference architecture on a Quanta design that we in Quanta had worked on that we first rolled into our data center. And that rack, as you see in that picture, is the exact same hardware layout, I think the exact same cabling scheme. When you're in an open source movement and somebody just picks up your stuff and starts using it, independently, no need for conversation, I think that's a sign of maturity. And just think, a few years ago, people thought this sort of thing was never going to happen for the enterprise. Maybe just the big players, but it's going there too. For us, we stay focused on the cloud, and I want to talk about the evolution of the cloud. I think today, if we think about what cloud wants and what cloud end users want, it looks something like this. We want the highest performance, we want the coolest technology, we want it at a very low cost, and we want to be free to take it wherever we want to take it. It's something like a free ride. I mean, we want our infrastructure to be that efficient that we can just build anything we can dream of. I think what we have today is more like this. And I don't mean to criticize what we have today, but we have built a vehicle that, while very efficient, is not really sophisticated down at the hardware layer like it could be. And in many cases, when we run into scaling challenges with this cloud that we have today, the message is, if you run into problems, just get out and push. Do it on your own might. Especially if you're having scaling challenges. That's what engineers are for, to figure out these really difficult scaling challenges in our system. And I think we need more. I think what the cloud needs is something more like this. We still want our vehicle, but we want it radically re-engineered underneath so that it's far more efficient than what we have today and far more powerful than what we have today. When you get under the hood of your vehicle and you start changing it, you get into experience that can feel a little bit like this. And it's uncertain for almost everybody, and it's dirty and messy work. When your car's working sometimes the last thing you want to think about doing is taking a risk to make such huge changes under that hood to get something better. We've been riding on this model for a really long time, but I think it's time for us to start working on changing it. Here's where we learned that lesson. It started with OnMetal. Okay? Most cloud users, when they build multi-tenant cloud applications, do it because multi-tenant cloud environments are very low cost and very flexible and easy to get into. You can get a virtual machine many places in just a few moments with a little bit of effort, and you can scale it elastically very easy. And many people start with a low budget and a great business idea, and they prototype on these clouds, and their app starts to grow, and they start getting noticed, and marketing takes off, and suddenly they're in hot territory. But that cloud doesn't necessarily hold up with them. And as they're going through their steepest growth curves and their biggest growing pains and trying to figure out how to optimize their app, they start to realize that this multi-tenant cloud that they're on is maybe not where they need to be. And where they really want to be at that point is a colo environment where they have all the control over the system configuration and all the details. And when we built OnMetal, we were trying to solve for that so that we could let customers be anywhere on our cloud that they needed to be, including a bare metal dedicated environment with that same ease of provisioning. But when you take out a hypervisor in a cloud, you run into problems. See, here's what hypervisors do to your performance. Okay? You have neighbors you're sharing the machine with, and sometimes it's unpredictable on performance, but hypervisors do a great thing to give you security and speed of provisioning and abstraction to make that experience really smooth. So we ran into a problem here. We want to give somebody something that's really elastic, and we want to give them something that's really simple to scale, and we want to basically say, how about the best of both? But we got to do something to make that change. So we did. I'll get into that in just a minute. But we delivered OnMetal, and here's what one of our key customers had to say about it. This is not the current cloud that he wants. He wants the next cloud. And he wants it evolved, faster, easier, more. Okay. So we had to break some stuff to give him that, to compensate for that loss of a hypervisor. And I'm talking about just one item here. And there are other things that will come in the future that will also need to go break. If you want all that security and you don't have a hypervisor, you have to do it in your firmware stack. And so in OnMetal, through OCP, we changed our firmware stack. We worked with our partners. We were into territory at that point that was no longer open. And we're an open company with OpenStack. So when we finished all of this work, we wanted to take all of that development work with firmware and some of the special integration work that we had with OpenStack and OpenCompute and give it back. But we ran into licensing problems. We ran into NDA problems. We ran into a part of our ecosystem that is still closed. So how do we take it further? I think the first thing we need to recognize is that open for us has been a work in progress. Okay, we started with racks and electrical systems and chassis, and that area we were able to improve and get huge returns. Facebook has been talking about it, all the savings that they've gotten by redesigning their systems, and we've appreciated similar sorts of benefits. And then we started getting in networks and disks and software, and it feels, all along the way it feels really good, but there's another piece of this puzzle that we need to break into if we really want to get to fully open system designs that give us all the freedom we want. We need to start getting into processors, memory systems, firmware, BMCs, open all the way through. And when we complete this puzzle, we can do some really big things. Now, we have been talking about for the last few years, I think since before Group Hug was demoed, about disaggregating the data center and taking other parts and converging them. But these servers that we have designed today, they're almost like our DNA. They're that fundamental to how we think and operate. And if you want to change the status quo, you've got to get in through movements like OpenStack and OpenCompute, and then down at the chip layer and make some really fundamental changes to your system. And I think every one of these logos that you see on this screen is ostensibly trying to tackle that problem. Our challenge is there's just a lot of stuff that has to be cleaned up, changed, and fixed to make that happen. And just like Open Compute, for some, was challenging new territory to break into on our supplier and creator side of the community, we're dealing with a similar challenge here. There's one in particular that addresses these issues and has kind of stepped out over that ledge to see what the new world looks like. And that's open power. So you think about the boundaries we're trying to push. We've got open software. We've got operating systems in Linux where we're open pretty much all the way through with the exception of some drivers. And we've got, with an Open Compute, an increasingly open environment with freedom to gain more ground than we have right now. And we need to keep moving. If you represent that another way, and you want to think of stacks or layers, you could say each one of these components has addressed these parts. And kind of like that puzzle, if we lay out a stack and we ask, what does open power add? Well, it doesn't do a lot in operating systems. We'll do a little bit with driver work there with some of these new components that we're building. Where it really addresses the stack is it helps us within the Open Compute community take on these other parts that still need to be enhanced and changed so we can evolve and build that next more efficient, more powerful vehicle. It's not unlike what Frank shared last year at last year's summit. Okay? We have consumers connected with technology and possibilities. And in the most ideal case, consumers would be connected to all the best technology for them, and the technology would just fly. Okay? And not unlike what Frank showed last year, but in a new domain, we have licensors for firmware and platforms and protocols that, for very good reasons up until now, have been controlling how that technology flows. It's gotten us to where we are today. We should be glad that they were there helping us do it. Unfortunately, at this point, it's slowing down the rate at which we can innovate. So we got all these ideas, just like we did in other parts of the stack, that are sort of stuck on licensing schemes. Okay, the flow eventually gets out, and we continue to innovate, but it's slow. Here's what we propose to do instead. Let's get to a model that has this same connectivity with an open licensing scheme. Now, some people say the whole point of these open movements is just to suck all the value out of these technology creators. Give it all back to the consumers. You know, it's all about the guy in his garage with a compiler and a web server and a cheap cloud server, and all he wants to do is just suck all the value away from everybody else. And you know, that stereotype is true to a certain extent in parts of our industry. True enough that it shows up on South Park. But this is not about mooching. This is about innovating much faster than we are today. If you think we're innovating fast now, I want you to contemplate the possibilities for just a minute. I want you to contemplate how much faster we can change these parts of the system, and they are changing. They're changing in a closed fashion today, and you're only getting limited vision into them, but they are changing. How much faster could we move our open source hardware movement and innovate if we got open at this layer? For us, the value propositions are all across our portfolio. We want to start in a certain area and then spread out from there, just like we have with Open Compute. But the value propositions are huge. In Open Compute, we get excited when we can do, 20, 30% more efficient. How about 2 to 3 times more efficient? How about 10 times more efficient? Hey, demos are out there already. If you go out and you look for open power in Redis Labs, you will see a Redis application, very popular, consolidating more than 20 servers into one. When's the last time we had efficiency gains that were that enormous, generation over generation in our servers? And think of the possibilities that we could deliver to our end users if we can deliver that kind of gain in our clouds. So how do we make that change? When we go break stuff, we don't want it to be like that mechanic where we get in under the hood, we change some things, and the system doesn't work anymore for the people who are driving. And open source communities can sometimes do that when they're first starting. They can create stuff that doesn't work well for almost anybody else but them. So here's what I think needs to happen, and I think the sooner it happens, the better. Open source developers are more like hackers than they are traditionally educated engineers and developers in most cases. So they are going to want to see the car and all its little pieces, and they're going to want to pick up little parts and explore them and tweak them and change them and experiment with them, right? They need the freedom to do that so that they learn and figure out how to innovate next. And then they'll work well with their partners to create this vehicle. So what's really different about this vehicle? I've been talking about it for a while, but what's changed? Okay, metaphorically, think of that Tesla. It has a different engine. It has a different fuel system. It has different power transfer systems. It's still a car, it still has a chassis, but parts of the system have been radically re-engineered to help make those gains. And some parts of the system have just been modified a little bit, okay? Some parts are more like the brakes. We don't have to change everything there, just parts. But of course, we got to remember tires, steering wheels. Those things matter. Because in the end, what we want the experience to be like for our end users is what the experience is like when you're sitting in the cabin of this vehicle. And if we do this right with that open source community, we can create something that doesn't look like a space alien system. We can create something that feels really good, runs really stable, and is really fast. So Rackspace is making a venture into this territory now. With our partners, Samsung, Mellanox, Avago, PMC, IBM, and a few others, we're going to create a new server that's based on open power that's much more efficient for our applications than anything that we have today. A bigger step function for us than what we got initially out of our first open compute servers, and we think you can do the same. But here's how we see it. Okay? It starts with creating a server, just like Freedom, just like some of the others. We are going to build a server, we call it Barrel-I, and Barrel-I will fit in an open rack. And it will run conventional switching, and it'll have all the standard power supplies and so forth. The parts that we're changing are what's inside the server. We're going to take advantage of all of the other work we've done so far. We're not trying to replace any of that. But here's what the server looks like. Okay? Some applications want one socket, one core, lightweight server, a microserver sometimes. We are looking at something that takes it in the other direction to address that spectrum. I like to think of this more like a mega server. Okay, there's a lot of cache, a lot of clock speed, a lot of memory, and a lot of I/O. So you don't fit as many of these into a rack. But what you do fit is 2 to 3 times faster than what you might create in that smaller server. And we're trying to create something that allows enterprise adoption a little faster. So we're doing work that allows for modularity in the I/O system, so people can change that part without having to respin the whole board. We're trying to bring hot swap drives and other components that people are used to there, things that we've done for other open compute systems that we run at Rackspace. And here are some images of what that server should look like when we're finished. There's half a Knox in there, along with all the rest of that stuff. So how does the future look once we get going here? Well, we take an open compute. We want to add open power. And we want to create an open power-based OCP server and contribute that back to the community. And we want that server to, under its various licensing schemes, be open all the way down to the silicon layer. We want to create a development environment that we can get value out of today that other people can go hack on. And already there are hypervisors and Linux distributions and some firmware. There's an open BIOS. If you go to GitHub and search for open power, you can find the open BIOS implemented as shipped in production on a number of servers that are already out there today, contributed by Google and others, over 420,000 lines of code. We want to incorporate an open BMC. We like what Facebook is doing in this space, so we hope to pull that in and take advantage of that. And we need to start doing work on cloud orchestration. It's pretty easy to get an open power server built into something like OpenStack today. We've already done it in our labs. But when we talk to our OpenStack developers and we say, you know, there's a lot of cool new memory and kinds of processing and storage, and we can make all these fundamental changes to have these huge step function gains. Once we get that basic stuff done and we're gaining all of that richness out of the basic part of the platform, then we need to start moving Our whole community needs to start moving into open source, open development, open specification for coherency, for the buses that we use, for the protocols, the memory systems, and so forth. And not everybody that's part of this movement needs to be a part of that. The people who want to be will be, and everybody will benefit. Once we get there and we've got these things running in production, just like we've seen with Open Compute, we can get to a new cloud, but we need developers to get us there. So I propose that we develop a system that is so powerful that they cannot resist wanting to use it. And I want everybody else in the community that's working on other chips and other platforms to think the same way. Bring us in. We can help you make your platform far more efficient for all of us if we do it together. And if we bring those developers in, we will have a new, much more powerful cloud with new applications, new capabilities, new end users. We'll construct a pie that is so much bigger and so much richer today than it is today because we've delivered all that extra efficiency. So our message to all of you is, if we want to make this world-changing technology in Open Compute, let's reach out to these partners and let's do it together. Thank you for your time. Oh, wait a minute, hang on. Sorry, I forgot something. Can we put the mic back on for a minute? People like to see printed circuit boards and get excited about this stuff. So this is the Barrel Eye motherboard as it exists today. It's just a floor plan right now, but we hope later this year you'll start seeing systems showing up in OCP labs with OCP certification test suites and all the other tools so that everybody else can start working on it as well. Thank you.
Did you forget anything else?
No.
Thank you so much, Aaron. You know what, Aaron, I said earlier that Aaron's one of my favorite people. Aaron is on our IC, and I have to tell you guys that every time I'm around Aaron, I learn something new. He brings something fresh. And the Rackspace team, they're integral members of the foundations. We really appreciate them.